Whenever you're streaming a video or hopping on a video call, have you ever stopped to think about what's actually happening inside your phone? There's this constant, hidden conversation going on, a secret language between your device and the network. We're going to dive into that world and decode the very signals that make 5G work.
Right. We've all heard the promises. Blindingly fast speeds, almost zero lag, connections you can always count on. But how? How does the network really pull this off? What is a fundamental change under the hood that makes 5G so much smarter than everything that came before it?
Well, the answer's pretty cool. It lies in a complete redesign of its internal communication system. See, 5G doesn't just shout louder, it talks smarter. It uses a whole new vocabulary of highly specialized signals. And that's what we're talking about today. This secret language, tuned for incredible performance and efficiency.
To really get why 5G's new language is such a game changer, we first have to look at how things used to be done. Let's rewind a bit and talk about its predecessor, 4G LTE.
Okay, so 4G had this one workhorse signal. It was called the Cell-Specific Reference Signal, or CRS for short. And this one signal had to do a ton of different jobs, everything from helping your phone understand incoming data to measuring how good your signal was.
The best way to think about the 4G CS is like a giant megaphone at a party. It was always on, constantly blasting out information to every single device in the area, whether they needed to hear it or not. I mean, it worked, sure, but man, was it inefficient. It just burned through power and clogged up the network for no good reason.
5G looked at that whole megaphone approach and said, no way, we can do better. So instead of one loud, inefficient signal, it created a highly efficient team of specialists where every single signal has one specific job to do.
And this table right here shows you everything. 5G basically retired that old, power-hungry CRS. Its jobs were split up and handed over to a whole new team. You've got the DMRS for decoding data, the CSIRS for checking signal quality, the TRS for tracking, and even a brand new player, PTRS, for tackling the unique challenges of millimeter wave. The key takeaway here? This isn't a small tweak. This change drastically cuts down on waste and saves a ton of power.
All right, so let's meet a couple of the star players on this new team. We're going to start with the two signals that handle the absolute basics, making sure data is actually readable and that your connection is as solid as it can possibly be. Let's kick things off with the Demodulation Reference Signal, or DMRS. Just think of this as the decoder key. Every single chunk of data that gets sent to your phone is locked, and the DMRS is the key that unlocks it. Without this signal, all that data would just be meaningless static.
Now here's the really clever part. In 5G, the DMRS is front-loaded. That means it's placed right at the very beginning of the data packet, so your phone gets the key first and can start unlocking the data instantly without any delay. This one simple change is a huge reason why 5G feels so responsive and has such low latency. So if the DMRS is our decoder key, then the next member of the team, the CSIRS, is like the network's super smart quality scout. Its whole job is to constantly check out the environment and make sure your connection is perfectly optimized.
And when I say it has a lot of jobs, I am not kidding. It measures your signal quality, it helps the network aim data beams precisely at your device, it fine-tunes the connection constantly, it keeps an eye on the overall health of the link, it even measures interference from other signals. It's a massive, massive upgrade in network intelligence compared to what 4G could do.
Okay, now let's talk about the really fast stuff, the super high frequencies that give 5G those incredible speeds. We're talking about millimeter wave. Now, these frequencies are amazing, but they also come with this unique, really tricky physics problem that needed a completely new kind of solution.
The problem is called phase noise. It sounds complicated, but here's the gist. At these super high frequencies, tiny imperfections in the hardware can create distortions in the signal. You can think of it like a slight wobble that can mess up the data and cause errors. So the engineers basically had two choices. Option A, solve it with expensive hardware. They could put incredibly precise and incredibly expensive components in every single phone, which would make all our devices way more expensive. Or there was option B, solve it with smart software by creating a new signal whose only job was to measure and correct for this wobble in real time.
And you guessed it, they chose the smarter option. They invented the Phase Tracking Reference Signal, or PTRS. This is a true specialist. Its one and only job is to compensate for that phase noise. This brilliant little signal is what allows manufacturers to use more affordable hardware in our phones, making those crazy fast millimeter wave speeds a reality for all of us.
So let's bring this all back home.
What does this secret language of signals actually mean for you in the real world? Well, that front-loaded DMRS gives you faster speeds and less lag. Getting rid of that 4G megaphone means much longer battery life for your devices. The super versatile CSIRS results in connections that are way more reliable. And clever little signals like PTRS are literally what make the future of multi-gigabit speeds possible.
It really just goes to show you the biggest leaps in technology aren't always about brute force and more power. A lot of the time, they're about smarter, more elegant design. And it makes you wonder, right? As our world gets even more connected with things like AI and the Internet of Things, what other hidden conversations, what other secret languages are being designed right now to power our future?